We're going to switch our attention now to working with quadratic functions in factored form. Although sometimes the equations start off in standard form like this one, where it's in ax squared plus bx plus c format, which means there's an x squared term for sure. There may or may not be an x term, and there may or may not be a constant. Once it's in factored form, you're able to get the zeros, and I'm going to show you how to also get the vertex and the y-intercept. So to start with, to get the zeros, you have to put it into factored form. So the first step is to select the appropriate factoring strategy. So to first start, we have a common factor of -2. So that means each of these numbers, coefficients, can be divided by -2. So we'll common factor out the -2. And when you divide the first by -2, you get x squared. When you divide the second term by -2, you get -2x. And when you divide the third term by -2, you get -3. Then what we have here inside the brackets is a simple trinomial, because you have an x squared, an x, and a constant, and there's, other than this that we already factored out, there's no number in front of the x squared. So now we have a simple trinomial. So we need to find two numbers that multiply to -3 and add to -2. And those two numbers are -3 and +1. So we're going to factor that as x minus 3 and x plus 1. So to find the zeros, you first factor it as much as possible. The second step is to set each factor equal to 0. So x minus 3 is equal to 0, and x plus 1 is equal to 0. And lastly, you are going to solve each of those equations. So if you add 3 to both sides here, we get x equals 3. And if you subtract 1 from both sides here, you get x equals -1. So those are your two zeros. So 1 0 is at 3, and 1 0 is at -1. Now that you know what the zeros are, your next step is to figure out what the vertex is. So what I want you to think about is the vertex has to be on the axis of symmetry. And the axis of symmetry is right in the middle of the two zeros. So the axis of symmetry is going to be that line right in the middle of the two zeros, and the vertex is on that axis of symmetry. So to find where that axis of symmetry is, you're going to average the two zeros. So the x-coordinate of the vertex, you're going to label that as xv. For the x-coordinate of the vertex, you're going to average the two zeros. So it's going to be 3 plus -1 divided by 2, which is 2 over 2, which is 1. So that's the x-coordinate of the vertex, and that's where the axis of symmetry is. Then, to find the y-coordinate of the vertex, so that's yv, what you're going to do is substitute that 1 into the equation. So you're going to take the equation and you're going to substitute 1 into it. So that's -2 times 1 squared plus 4 times 1 plus 6. And using your calculator, you would get that that is equal to 8. Now, to get the y-coordinate of the vertex, you can substitute the x-coordinate of 1 into the original equation in standard form or the equation in factored form. It doesn't matter, you'll get the same answer either way. So that means that your vertex is going to be at, so V for vertex, is going to be at an x coordinate of 1 and a y coordinate of 8. So your y coordinate is going to be up here at 8. And then when you go to graph that, it would look something like this. Now, I didn't put this next part in your mindful notes, but I just want to remind you, if you need to find the y-intercept when it's in factored form, so if your equation is in factored form, you can get the y-intercept by substituting 0 in for x. So that would be negative 2 times 0 minus 3 times 0 plus 1, which is negative 2 times negative 3 times positive 1, which is 6. So your y-intercept would be at 0, 6. And you can see that right there. That's where your y-intercept is. So I didn't put that in, so if you want to add that, so to find the y-intercept, you substitute x for 0 and solve.